Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to power systems, and so far we have discussed about the general principle of power transmission and distribution, the basic principle. First one is the AC power supply system, or the high voltage AC power supply system, and then the high voltage DC power supply system. The basic principle, the concept, the block diagram, everything. So in this video we will be discussing about a comparison, what are the advantages and disadvantages of each of these two methods, okay, the HVAC and HVDC transmission, because every system, every method, it has its own merits and demerits. So we have to evaluate both the pros and cons of this, the thing, and then according to the operational requirements and various other factors, we have to make a decision, a choice about a particular method. Okay, so we have discussed about the high voltage AC system along with the various elements and the single line diagram. Okay, then also the high voltage DC transmission. So please watch these two videos first and then watch this video. Now we will be discussing about the basic comparative analysis of AC and DC. So first, the advantages of the AC supply system. The first and the most important advantage is that in the AC supply system, the power which is generated, it is very high. Okay, it is very high as compared to that in DC. Along with the added advantage which is related to here, that this high voltage can be suitably manipulated, that is, we can increase its value or decrease it, stepping it up, stepping it down, with the help of suitable AC transformers. Okay, whether it is single phase or three phase, accordingly we can use suitable transformers and we can increase or decrease its value with the help of suitable step up and step down transformers at different strategic points according to the operational requirements. So it allows us to transmit the power at the required voltage and to distribute it at safe voltage values, because depending upon different locations, like I said in the AC power supply scheme also, different users have different power requirements, different voltage requirements. So depending upon that, voltage has to be stepped up and down. So the AC system allows that thing. Okay, and then also another important advantage is that the maintenance of the AC substations, okay, the receiving station, the distributing substation, everything, that is comparatively easy and is less expensive, it is cheap. Okay, so that is another advantage of AC system. So these are the three main advantages of AC system. Then the disadvantage. Okay, so one of the disadvantage of AC system is that the transmission and distribution conductors which are used for transmission and distribution of power at different points, those conductors, which is again divided into two types, overhead and underground, so that require that transmission and distribution line, it requires more copper as compared to the DC transmission and distribution line. Okay, so the AC requires more copper means more cost, more expensive. Okay, so that is one disadvantage. Then the design and construction of the AC transmission line and distribution line, it is more complex. Okay, it is more complex, more complicated than a DC transmission line. Okay, so this is the second disadvantage. And there is another thing which we'll discuss when we'll discuss the various parameters associated with the conductors used in transmission and distribution line and power supply systems. It is called as the skin effect. So what happens in skin effect is that in the conductors, the transmission distribution conductors, the alternating current, it tends to it tends to go to around the surface, the ends, okay, the ends of the system. So in skin effect, the alternating current, it concentrates near the surface, okay, and the whole cross-sectional area of the conductor is not utilized. So the alternating current only it concentrates around this region, the end surface, the end areas, and not the whole cross-sectional area is utilized. So it has its reason. We'll discuss it in detail during our analysis of the conductors used in transmission and distribution lines. So the resistance, inductance, capacitance, we've discussed the basic concepts, but then we'll discuss it, how it affects the power supply systems. So for now, you just understand that this, because of this skin effect, especially in AC or alternating current, the AC line, the alternating current, it only concentrates around this end surface areas, and the whole cross-sectional area is not utilized. Okay, so this is another disadvantage of the AC supply system. And then the AC line has capacitance along with inductance also. Both things come into play. The frequency dependent parameters come into play. So there is a continuous loss of power due to that. Okay, so here we have discussed the advantages and disadvantages of AC system. Then comes the DC system. One main advantage of DC transmission is that for AC we require 3-phase 4-conductor system or 3-phase 3-conductor system, depending upon what type of configuration you use, whether it is star or delta. But in case of DC, only 2 conductors, 2 wires are required. Okay, that is one advantage. Less conductors means less cost, less design complications, less complications in the analysis and detection of faults. So everything is less complicated and also less maintenance cost. Then there is no inductance and capacitance, no frequency dependent components in DC. So there is no phase displacement, no phase difference, and the surge problems are also absent in DC transmission. Okay, this is the second advantage. Then again, because of the absence of inductance, the voltage drop across a transmission line, because a transmission line has both resistive, inductive and capacitive components. The inductive component generally dominates. So the voltage drop across the inductive reactance, there is no such thing in DC system, for the same sending and receiving voltage. Okay, so it has better voltage regulation. Again, the same thing as this, because of lack of frequency dependent components, it has less voltage drop. And there is no skin effect. Skin effect only affects AC system, no DC system. So the entire cross section area of the conductor is utilized, whereas in AC system only the end areas, this end surface areas, it is used, because the alternating current only concentrates around the end surface areas, and these portions are generally not used. Okay, again it depends upon the magnitude, the material of the conductor, the design, everything, but in detail we'll discuss it in a separate video. Then here for DC system, for the same operating voltage, the stress which is put on the insulation, that is less in case of DC system as compared to that in a AC system. Okay, so the stress on a DC system in terms of insulation, it is less. So therefore a DC line requires less insulation. So less insulation means less cost. And again a DC line has less corona loss and reduced interference with other communication lines. So again corona effect we'll discuss in a separate video, it is a thing. So for now you understand that it has less corona loss, the DC line, and it has less interference with the other communication lines which is used in communication systems. Okay, then the high voltage DC transmission, it is free from dielectric losses, again because of lack of capacitance, and there is no stability problems and synchronizing difficulties in DC transmission system. So if you see this, there are a lot of advantages of DC system, but still AC is more used. It has its own reasons, because for any kind of requirement, for any kind of use, the main factor which plays a huge role is the cost considerations. The AC is, because even if it has its own disadvantages, it is more cost effective as compared to DC. But again DC is also used in some cases. We'll discuss them in detail when we'll discuss the upcoming videos on power systems. We'll discuss in which cases AC is used and in which cases DC. So we have discussed the advantages of the DC system. Now we'll discuss the disadvantages. In case of DC, the electric power, it cannot be generated at high voltages, up to the point which can be used in AC system. Okay, and it is mainly due to commutation problems. So the level up to which we can go in AC, the same level we cannot go in case of DC. So magnitude of DC voltage for transmission, that is less. Again stepping up, stepping down, it cannot be done for DC voltages at high voltages, again because of operational complexities. And the switches and circuit breakers that are used in DC transmission systems, they have their own limitations, again because of constructional complications. Okay, so we'll discuss all of these things in separate, actually all of these things are separate chapters, separate areas. Here we are just trying to cover it as a whole, AC versus DC transmission. We'll discuss them in detail. So these are some of the disadvantages of DC transmission. So we have discussed the advantages of and disadvantages of AC system, and then the advantages and disadvantages of DC system. And as I said, mostly AC is favored as compared to DC, mostly, but DC is also used, but because certain operational requirements, we prefer DC as compared to AC, but mostly the AC power supply system is used. Okay,